Hi everyone. Soon you should see my screen. Uh, Today I will tell a story how we measured performance of different editing applications running in Linux. To give you a little bit more context, we are working basically, it's a text editor that runs on simple low power Linux machine with a single CPU, maybe multiple cores. I'm not sure right now, but basically we have very uh, low performant, power efficient hardware with a keyboard and screen, and we code a text editor for this hardware. We already had a text editor written in JavaScript, written in web technologies. It is Electron with everything that Electron comes with, such as like basically it's a browser that renders HTML, that works as a browser, and everything. We were getting feedback that our editor is pretty slow, especially if you type fast. On the keyboard, everything appears slowly. Um, so our task or our goal right now is to optimize this typing performance and the performance of UI and everything on this device. As I said, device runs Linux, and I think it used to be very standard setup on Linux. Maybe it's not right now, but we have Linux, we have X server, and all other apps that we run, they are either like background daemons or they connect to X server to render everything. In order to begin, I shared my iPad so I can draw something. I wanted to tell you more about this. I'm not sure how familiar you are with UI programming and everything on Linux. So I'll try to give a very short introduction of how everything works. Um, Basically, the main component for rendering something on the display when you run Linux is the X server. X server is an application that is able to draw many things on your display. How to better describe it? So we have Linux. If you run Linux on a CPU with little hardware or as little hardware as possible, just a normal PC maybe, when it boots, it interacts with your hardware. Linux kernel interacts with your hardware, like with your keyboard, with your CPU, with your memory. If you have a graphical card, it can send instructions to the graphical card. What else? It also can deal with displays. What is display? How do we show graphic on the display? Um, Basically, display is a array of pixels. I think we can call it array of pixels. Each pixel is mm, each pixel can be represented by multiple numbers to code the color of this particular pixel. So basically, display can be represented as an array of pixels And if you want to change a pixel on the display, you would supposedly go to this array, change one element, and the pixel will be redrawn on the screen. However, it's not very it's not that simple because displays that show graphics, they have refresh rate, and if you update your pixel while display in the middle of updating its screen, you will have different artifacts on your displays. We have code that try to synchronize updates of those arrays of pixels with display refresh rate in order not to have artifacts. Basically, part of Xserver does it. It knows the refresh rate of the display and can facilitate updating this array of pixels. So we yeah, what I wanted to say is just it's pretty hard to manage or to update this array of pixels directly. And therefore we need one more layer of abstraction or something that would help us to update those pixels safely. This array of pixels in Linux called frame buffer. And basically, frame buffer is available for coding, for changing as a device. In Linux, you interact with kernel. Your program interact with kernel and give commands to kernel through files. And we have special files called device files, and we have a device file for frame buffer, which is basically represents array of pixels. And if our program open this file and try to write to this file, the picture on display could be changed. Maybe it's not that simple. I try to simplify everything, but basically that's it. If you don't want to use Xserver, you could try to use frame buffer. And if you would try to program for Raspberry Pi, for example, I think you don't usually run Xserver on Raspberry Pi, but maybe I will. Yeah. If you're interested, you can study how to program graphics for Raspberry Pi, and it's I'm almost sure you don't use Xserver there. You use lower level abstractions to interact with frame buffers. So moving forward to the Xserver, we have frame buffer. We could change it. We don't because it would be very hard. Therefore, we use Xserver, which would update frame buffers for us, and Xserver will gives us nice API to draw different things on the display. What kind of different things? And why Xserver called Xserver actually? Xserver called server because every program that want to display something using Xserver connects to Xserver using network. For example, if you run browser, I'll put a rectangle over it. If you run a browser program on your machine, browser program, in order to show a window on your screen, browser program connects to the Xserver and send instructions, drawing instructions to the Xserver via this connection. This connection by default, or it abstracted to be as a network connection, like a TCP connection, and we just send bytes through this connection, back and forward. We send something to X server, and X server send something to us. We usually don't do this, right? We don't connect to our X server via network. However, it's very useful. You can run a Linux machine with a display somewhere in a network, and then connect with from your computer, or run your program on a computer without keyboard, without screen, and send commands to the X server on different machine, and everything will be rendered well. That's why it's called server, because all the other programs connect to this via network. It would be inefficient to always have this communication go through the network stack. Therefore, there are different simplifications. For example, you may connect to X server using file sockets, which acts like network, but they are managed on the single machine within a single Linux kernel. It's much more efficient than going through network. And there are some optimizations that allow client programs to use shared memory and communicate with X server through shared memory. That's I think would be most efficient way for our UI programs to draw something on the screen. It's important for my demo in the future, so please bear with me. Maybe it's not very, you didn't want to dive that deep. Besides I told you why it's called X server. I want to tell you also what other nice things X server does, except it receives instructions to render something, to render lines, to render windows, yeah, to render, like, just you may try to paint some pixels on the screen. X server also manages keyboards, mouse, and probably other input devices. So if we have a keyboard device or if we have keyboard connected to our computer, it is a keyboard device on Linux. X server could connect to this keyboard device, and when you type something, the key code or code of the key you just pressed will go to X server. Okay, I think the input keyboard 0. So if you type something, there is a code that appears in this device file, like, I don't know, an example of code. It goes to X server. X server may modify this code, may do something with code, and it just wraps it up in a nice event, X input event, and X input event E9, for example. And this X input event will be sent to our application via network or via socket, via the connection that was established at the very beginning. So in addition to receive instruction like draw pix map with coordinates, in addition to receiving some drawing instructions from clients, X server also could send some input events to our clients. Those events are described in X protocol documentation. It's huge. The protocol is huge. And there are some extensions to this protocol. For example, X input, it could be not in the main specification, it could be in X input specification, and there are like different optimizations that were accumulated during years of people using X server. So that's, I think, the basic description of how the stack looks like. Maybe you have questions at this point, so I may explain something, and until I go forward, showing how we measure performance of different applications. Okay. So this is the setup we have on our device that runs Linux and runs X server and everything, and runs UI application. This is the setup we have. We were not satisfied with the performance of our app. And by performance, I mean like when you type, the letters on screen appear slowly. Like you type and it's noticeable. There is like, it's very noticeable when letter appears, and it could be like half a second lag. We were thinking about rewriting our editor application, but in order to decide what technology to use to rewrite this editor app with, we wanted to benchmark like different things. First of all, currently we have browser. Basically, it's a Electron app, which means it's Chromium application that renders web elements, I don't know, renders web pages, and therefore all the maybe overhead that a browser has, our application will have. That is the first approach. We could use our current application and optimize it, which basically means Chromium. Maybe we can optimize it so it will be performant enough for us. Second approach that we were thinking of is Tauri framework. We wanted to get Tauri framework, and basically it's the idea is very similar to Electron, except that it doesn't run Chromium, it runs WebKit as a web rendering engine, and Tauri facilitates writing all the code in Rust in a position to writing your application code in JavaScript if you go with Electron. And you can go a level deeper. You maybe don't even need a web rendering engine, because it's a simple UI application. Maybe not simple, but it's a UI application, and people used to create a lot of native UI applications for computers, right? We don't, and they're like, they didn't use web engines at all. So another approach would be to write a native UI application. However, this native word means very little things. Like, right? What would be native? Do we write application that we can write an application that interacts with X server, right? It connects to X display and sends different instruction. Draw a line, draw a window, like please handle mouse, something like this. We would call it a native UI. But writing applications like this using X server or X protocol instructions is very hard. Nobody, very few people, very few teams nowadays do this. Because protocol is complicated, protocol is huge. You would write a lot of things from scratch, such as font rendering, if you want to support multiple fonts, and we most likely want to support multiple fonts, or at least we want to support multiple variants of the same font, because it's not just editor, there are some UI elements. So writing, we would call it native, but it's very hard to write X X application. By the way, there is very nice to give you a little bit of idea how X application looks like. There is a good website, X11 Conservancy Project, that basically collects very old applications that were written to use X server to draw different things, and they are from like 90s. They are from 90s. It's x11cp.org. If you are interested in history, in legacy applications, you can go and check. For example, there's like air navigation app for pilots that can help to plan a how do you say it, road through road in the air. I would say this, and I believe somebody may even use it somewhere even nowadays. And there are a lot of nice applications if you are interested, and you can find more. I think there are different websites that have this those applications. As I said, it would be very hard to code application like this, and it probably, as you can see, it most likely won't look very nice. It won't look very nice, especially that we don't need scroll bars, we don't need everything. No, sorry. It would be very hard. That's I would stop from this. What then? What should we do, right? What do other people do nowadays if they want to write or want to create a native UI application? Basically, there are frameworks that allow you to write UI application. Such frame you've most likely heard of GTK. If you use Linux and you use GNOME, then and you run some applications in GNOME, those applications use most likely, not all, but most likely use GTK framework. What another if you use Linux and you use KDE and you run applications there, then some of those applications most likely would use Qt framework. I guess there are a number of such frameworks. GTK are just the most modern one. They support a lot of convenient features. They look nice. they look nice. The teams that work on those frameworks work or put a lot of efforts to improve accessibility, for example. They take care of font rendering and everything. And not only font rendering, in addition to uh, hardness of rendering different fonts, it's also not easy to render text, right? Because when you write text in editor and it doesn't feel on one line, you need to wrap it. So the word should go to the next line. This is very complicated logic, and if you write an application on X, you will need to handle it yourself. But if you use a UI framework such as GTK, this could be handled for you by the framework. And basically, it's like a library. You use GTK library, which means you use different GTK primitives. Like it could be a window, it could be a widget inside this window. And there are GTK already has many different widgets. For example, like it could be a list widget, it could be text editor widget, and using GTK API, you could combine those widgets, place them nicely within a window, and then tell application to render this window, which basically will execute some of the GTK code that would send some of the instructions to X server. GTK will be kind of like a proxy for your application for sending instructions to X server. And with, as I said, GTK is modern framework. It has a lot of features. It looks nice. It renders text almost without, almost as we wanted to do so. Yeah, it has some issues. We could work around them. But yeah, so we wouldn't write a native UI, like native UI application using plain X instructions, but we would use a framework for this. Yeah, so if we didn't consider this option. Instead, the third option we considered is native GTK or like GTK app. And we come up with this list, and we wanted to measure the rendering performance or performance of those proof of concept applications in different frameworks. And I think we came up with very nice idea how to measure this performance, and just want to show you how we did. What we a bit more about UI applications. Even if you have a GTK app, it needs to send instructions to X server, or there are alternatives to X server to render everything. So we write a GTK app, it sends instructions to X server. We found very nice tool which was created long time ago. It's called Xtrace. It doesn't even show me Google. Yeah, there's GitHub. So basically, the latest code on GitHub is 8 years ago, but it works. And this is the tool that acts like a proxy between your application and X server. And it could output every command your application sent to X server and every command or every event X server sent to your application. Xtrace. Thank you to developers who created it many years ago. It helped us a lot. This old util that surprisingly works very well. Yeah, so our idea was to measure. First of all, we launched Xtrace. We looked how those commands between this communication between our app and X server look like, and we came up there with the idea that we can measure time between or starting from input event being sent from X server to our application to the time when our application finished sending all the rendering instructions to X server. And this would what we would call the latency of our application. That's what I wanted. That's it for what I wanted to draw. And I think I will finish drawing for now and will share my screen to show you how this Xtrace application works and how we measure the performance. If you have any questions regarding what I just described, feel free to ask.
What is the language for the GTK framework?
GTK is written in C, but when it is compiled, it is available as a shared library in Linux system. And as I understand, you could use shared libraries from any languages. You just need special bindings. For example, if you write script in Ruby or in Python, you could still call code from compiled uh, code from shared libraries. So theoretically, there should be bindings, GTK bindings, even for Ruby. Yeah, basically, how it would work. Oh, sorry, I don't share my screen. I love Google Meet. Can share my screen. That's fine. No, it's not fine. I need to share my screen. One second. You should see my screen now. So there are some, I just Googled real quick Ruby bindings for GTK. And I believe there should be some libraries, Ruby gems that allow you to call GTK shared libraries. Basically, you can write applications in almost any language. However, it will be slower than if you write your application in C, for example, for the same reasons as it is the application written in Ruby runs slower. I don't want to go. It's a rabbit hole. Sorry, don't want to go there. For our proof of concept application, we chose Rust to write this proof of concept application. Do you see my screen?
Yes.
Yes.
Cool. So in order to test everything and to demo for you, and we were testing in the same environment, we created a simple Docker image where we basically install Xserver, some virtual display device. We install VNC server, so we could, when we run Docker container, we could interact with applications running there. Also, some applications I want to show you. There is Node.js. It's installed in order to show you Electron application, and Rust. Again, I use it for compiling our proof of concept GTK application. Yeah, what I wanted to show you first. I probably won't walk you through the code of the GTK app that we have written, because it's Eugen who wrote it and he can explain it better. But as you can see, it's very little code. What I do here, first of all, when I start my Docker Compose services, I run Xserver first, then I run VNC server second, and basically it's endless loop. How it works, if you just, I may restart it. Yeah, so Xserver started, VNC server started, and we can connect to this VNC server. I also map 5900 port 5900, and this is the port of the VNC server. I connect to it, and you can see I see the display that Xserver manages. You can notice that my cursor looks as a cross. This is what Xserver by default does. It draws cursor like this, and I move it. It also redraws it at different places. This is Xserver. However, we don't run any applications right now. What we want to do next, I connect to the container I'm running, and first of all, I will start Xtrace application. Trace. in order for your app to connect to a specific display, all displays are numbered. We started our X server with display number 0. However, when you start Xtrace, I tell Xtrace connect to display 0 and pretend to be a display, some other display, and Xtrace pretend to be display 9. It acts as a proxy. So I need to, in order to run my application, I need to connect to display number 9, and everything will be proxied to display number 0, which is handled by Xserver. So first thing I want to do is to remove some interesting optimization I want to specifically mention. I would run GTK editor, gedit. I would run gedit first. This is Xtrace terminal, and here's what it outputs. If I open it in here, you can notice that when I move my cursor, it's like a lot of events being sent back and forth between our application and Xserver. If I move my cursor out, everything works okay. Also, you may notice that my cursor is blinking. And yeah, every blink there's no magic, right? When it blinks out, every time anything changes, we need to send instruction to Xserver to redraw this area. Again, there is no magic thing that could do this for us. We like deal with it. So how do we measure typing performance? We could wait until it stops blinking. There's some, I guess it's GTK who optimized this code the way that if you don't type anything and the window is not focused, stop re-rendering those blinked cursors. I'll draw a lot of lines and I try to write a letter. If we go back, usually, so it's a lot of instructions, as you can see. I can't even scroll. Yeah, we just typed one letter, a lot of instructions being sent. We noticed that it happens especially when window was unfocused and then focused, it sends a lot of instructions. However, if you just continue typing, it doesn't send that many instructions. The challenge we faced is that it is very hard to distinguish events, like letter rendering events, from cursor blinking events. We can probably see here, right? We can see that Xserver sent us Xinput extension kpress event. Then in other direction, our application or gedit application was sending some get property, set property instructions. And then at some point, it's also convert selection, create window, not sure why it does it, replaces something, blah, blah, blah. And somewhere here there should be rendering instructions. Create counter, set counter. We don't know why those events look like this, but we just studied what we had. Some properties, I guess, shape request, mask operation. There are some could be some available rendering instructions. Also, I believe it started 155 These instructions look like rendering instructions. We create a picture, we fill some rectangles, and the coordinates look okay. Something called composite glyphs, blah blah blah. Blah 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 blah. I guess rendering instructions finish here, and then they are finished faster than key release event came to our application. They finished, it started at 155, finished at 158. So about 3 milliseconds, I guess. If I, yeah, 3 milliseconds. It took the app 3 milliseconds to render. However, studying those logs is very hard because of these blinking cursors. Oops, I stopped the wrong thing. Therefore, we tried to study how to disable this blinking cursor, and we found some GTK settings that allow us to stop it blinking, and it helped us a lot to measure performance. Things in to measure performance. If I launch the app again, we can see that cursor doesn't blink anymore. And now we can better measure latency between kpress and rendering instructions finished. Again, it does a lot of weird stuff. We usually didn't study such things. Yeah, here we go. Xinput kpress event being sent to our app at 144. Then something happens. Our app does some calculations, exchange data between our application, and we can see that rendering finished at 159. It means 15 milliseconds latency. And after we finished rendering, or we finished sending rendering instructions to Xserver, we released the key. So I'm pretty slow at releasing my key when I click something. Let's try one more time. Now it's 899 and 912. So it's like 13 milliseconds of latency for this gedit application. That's how basically that was the main part of my talk. Sorry, I always stop X-trace. We also studied Electron app. Please don't pay much attention to like absolute numbers right now, because I run everything on my computer, not on the hardware that we have, that our application will be running. I just show the idea. How do I start Electron here? Makes Electron sandbox. Oops, sorry. I need to specify X-trace display. Here we go. And again, I type something, and we can notice that keypress event comes at 347. rendering instructions are finished at 3:52. So it took about 5 milliseconds to render, to send all the rendering instructions for the letter I typed. And try with other letters. It's, yeah, again, 7, 6, 7, 7, 8 milliseconds. Interesting thing you can notice. Not sure I noticed it before in GTK app, but you may notice that rendering instructions for Chromium application, for Electron application, look very different. There are fewer of them, and they are more precise, I guess, more readable, and also there is a word MIT SHM. It's what I learned. It's indication that that the application uses shared memory to communicate with X server. We can notice like at which coordinates what was re-rendered. Again, it was very valuable to disable blinking of cursor. Works pretty fast. Also, you can notice that there are no events like I don't know, create picture, draw fill rectangle, create rectangle. We only have one simple event being sent from Chromium to X server is about put image. That gives us the idea that Chromium does all the rendering on its own. It doesn't use any GTK primitive GTK widgets. It does all the rendering on its own. And you can see it does it pretty fast. It is everything could be changed if we write a lot of, I can't write a lot of words here. Maybe I can, I think, maybe I can. No, I type very slow, even though I try to type very fast. The more text we have, the slower it become to draw something new. Maybe it won't be very noticeable on my computer. Right now, the performance is 10 plus 16 milliseconds. One more time, 8 milliseconds. One more time, 13. So that's how you can measure latency of your application regarding the rendering anything. It could be text, it could be something else. Yeah, basically that's what I wanted to show you. Not sure I need it, but we also have GTK, plain GTK application, which we can run target release app. Sorry, I'm wrong. Target release app. It looks more like gedit, and again it is 4, and then something happens, it's 32 at the end. I forgot how we disabled. Eugen, are you here?
Yep.
How do I disable?
GSK render, probably.
Like this?
The second letter is S.
Are you sure?
No.
Cairo? What renderer should I use?
Cairo.
Our device doesn't have um, graphical card, therefore you can't accelerate rendering graphics, and that's why we try to disable it when running our application. Usually it helps a lot. Well, it helped. Right now it's 9 milliseconds. One more time. It's again 9 milliseconds. There are fewer rendering instructions being sent on device, on the hardware we have. It was very noticeable. It like when we tried to use GPU acceleration when no GPU is available, it was like, I don't know, 100 something, 150 millisecond latency, and it made us very sad. And then we realized that we just need to disable this GPU acceleration, and everything works much faster. It's 3 milliseconds for this last letter. It's 3 milliseconds again. It's 5 milliseconds. I guess it's pretty comparable to the Electron app that I showed you before. However, there are different things to consider if you go with Electron, especially if you use text area for rendering text, or yeah, it's a subject for another huge discussion, how to optimize text editor in browser. That's what I wanted to show you. I wanted to show you how we measured latency of our application. By latency, I mean time between input event, time between I press the key, and all the rendering instructions sent to X server. That's how we did it. I guess our main idea, or at least what we propose to rewrite our current Electron app to the GTK app, and yeah, that's it. That's what I wanted to show you. I guess we can finish if nobody have questions then.
Can we make a little I don't know, like, can we stay just for 5 more minutes to ask you some questions? Do you have time?
We can. I do.
Okay. So I will be the first one. I was just curious about the switch from Electron to GTK app. So according to to your demo, there is not such a huge difference in rendering time between Electron and CDK, and I was wondering, like, what was the key motivation about this switch? Because the numbers are not that different.
We are not switching right now, but that's what we propose. Browsers are very good at rendering. They a lot of man hours were spent on optimizing rendering and everything. And yeah, browsers are great at rendering different things. However, we, in addition to do the rendering, we also need to run some background code. which could be a challenge in browser with JavaScript, especially if like our app has many different services, and in theory we can optimize them, but it still won't be as performant as if we just run simple Linux threads or simple Linux processes. Also, what I showed you right now, those are data from my computer. On the target device, we were measuring things on the target device. Numbers look a bit different. Electron, what we measured for electron starts from 40 milliseconds. Like every time you type something, it is 40 milliseconds latency for rendering. If we compare this to GTK app on the device, for GTK app on the device, it is more like 15, 20 milliseconds. It's a bit less stable. Also, Electron or web app start to perform very poor when you have a lot of text. If your document that you put into a text area is long, the performance is very slow. I guess you can replicate it if you open a tab with a text area and put like a book into the text area, it will be very slow. So we measured those cases, and right now we handle it with very smart and complex and maybe complicated system. We don't use text area for text editor on this device. In our current application, we use content editable, and we split our documents on blocks and only put on the page blocks that user currently works with. When document is opened, we load the very recent block, while in the background we continue adding other block. So it's very complex system, and the fewer complex systems you have in your app, the better. GTK, from what we observed in X-Trace, GTK has similar approach to what we did with content editable, but it does it with native text editor widget. So it would be good for us.
Thank you for the answer. It triggers one more question. So choosing between GTK and Qt, why have you decided to continue with Qt with GTK? Because I've always had an impression that Qt is specifically designed for optimized graphic rendering, and I'm curious if you had the chance to benchmark Qt-based solution on the device. Yeah.
No, we actually didn't study Qt. I guess our idea was that it won't be much more. It won't give us performance boost, because from what I saw in GTK apps, I used GTK apps, I used Qt apps, and they are the same. The performance is the same. The difference mostly is in how they look, right? Like how standardized icons look like, how windows on Linux look like. That's how different widgets look like, and we won't use those widgets with icons and with UI. So we didn't test it, but I believe it will be the same. Maybe it's actually worth to try it.
Yeah. So one of the greatest benefits that Qt brings are its data structures. So as far as I know, there are various data structures for handling huge amounts of texts, for example, and they are pretty optimized. By data structures, I mean some specific types. For example, if you write in Qt, you would probably use C++, and instead of like generic C++ data structures, they use some custom ones like QString or QChar. All those types are designed for handling huge amounts of text and data. So that's why I was asking.
GDK actually is not far away from Qt here. It's also a library that brings a lot for working with text.
Cool. I didn't know this.
Also in GTK, well, Qt also, I believe, has it. Like, but since we have Electron app, it uses Chromium. Chromium uses. No, it's wrong. Maybe not. Chromium uses GTK for some stuff, and we rely on it. For example, in input methods. If you write in Korean or Japanese or Chinese, you don't type hieroglyphs. Hieroglyphs doesn't map to your Latin keys one by one, right? Therefore, I'm not sure I pronounce or I know those terms right, but there's phonetic typing, right? You type how particular hieroglyph sounds, and then you have a special window that shows you different like options for different hieroglyphs that sounds like what you typed in Latin.
Qt, by the way, based on the same libraries the GTK uses. They have different mapping, so slightly different interface to work with this, but underlying libraries are the same, as well as rendering the text. So the bugs with rendering text that we encountered, they also exist in Qt. So they share a lot.
Okay, thank you guys for the very detailed answers. Does anybody else have any questions to ask?
I slightly disagree that browsers are really good at rendering. They are on our machines. But that's it. All the optimizations rely on either multi-threading or a lot of memory. Once it's about slow performant devices, IDAP, it's really performant.
Yeah, that's a good comment. The real data was 40 milliseconds, consistent 40 milliseconds for very plain single page Electron app comparing to, I mean, single page, it's like basically index HTML with text area.
You probably could share the numbers that we received, because once you type more, we measured long document, and the long document on WebKit is like Dima typed for a minute. Starts increasing drastically. While with GTK, we handled 10,000 paragraphs of text, and there is no difference.
And our current application with all the logic we have right now with all the background job that we do, has more than 100 milliseconds of latency.
Dima, are you going to share something?
I'm sending it in Slack.
Okay. Okay, guys, just one more call. Do you have any questions?
I forgot to show you, but there's editor that written in plain Xserver instructions. It's called Xedit, and latency of Xedit is 1 millisecond, even on the device.
1
But-
millisecond. Like,
Yes,
it's
consistently, always 1
Yeah.
millisecond. Yes.
It's worth noting that it doesn't render fonts. For rendering fonts, we'll need to bring library, and you most likely will receive your 10 milliseconds only. Just for rendering letters.
Okay. It seems like we are good to finish our meetup now. Thank you, Dima, for the great presentation and for the very deep diving into the Linux internals and Xserver internals and all the stuff. That was very interesting. And thank you, everyone, for coming today. And if you have any more questions, you can continue in the Slack. That's it for today. Thank you one more time and have a good week ahead.
Thank
Thank you.
you.
Thank
Bye.
you.
Bye.